My name is Frank Princiotta, retired U.S. EPA Research Director, and I'll be giving a presentation entitled, What Will It Take to Minimize Serious Climate Change Impacts? And the source paper's website is listed below. We'll be talking about what emission reductions are needed to meet the global community's target, which is to keep warming below 2 degrees Celsius, preferably no higher than 1.5 degrees Celsius. What technology and human behavioral changes will be necessary to achieve such emission reductions, and are they possible? Well, let's talk about the Industrial Revolution and what it's done to the atmosphere. And this is a plot of the three greenhouse gases: carbon dioxide, methane, nitrous oxide, the three most important greenhouse gases, and the concentrations in the atmosphere of these gases over the last roughly 10,000 years. And you'll note I've added that the red star, I've updated the data. This was a 2007 graphic. I've updated it now to 2018, and you can see really the dramatic increases that humankind has made in terms of atmospheric concentrations of these key greenhouse gases. Most critically, carbon dioxide before the Industrial Revolutions was at about 280 parts per million. It's now closer to 410 parts per million and going up. This is a powerful graphic that helps to quantify the depth of the hole that humanity has dug. The way this works is the blue part of this graphic, basically a reconstruction of temperature all the way back to 10,000 BC up to basically the beginning of the Industrial Revolution. And then we've added the red graphic, which projects warming to 2100. I've also adjusted the graphic a bit to include warming from 2010 to 2016. And it's important to note that as of 2016, the planet was warmer than any time it has been in the last basically 11,000 years. And many of you may know that historically, the blue component of this graphic used to be referred to as the hockey stick graphic. And it was very controversial because the deniers in particular were not happy to see information suggesting that we were already warmer than we have been over the last 10,000, 11,000 years. But I would argue that given the red component of the graphic, which shows us moving all the way up to 4 degrees Celsius plus later this century, maybe a scythe is a more appropriate model than a hockey stick. Well, we've already talked about the warming the planet has experienced. The next question, and the logical question, is, well, what is humanity's role in such warming? And as I think you'll agree, once you take a look at this graphic, that greenhouse gas forcing is needed to explain the observed warming. And this is analysis from the Intergovernmental Panel on Climate Change. And what they did was basically plot up warming, which is the black plot, and then basically compare that to what the models would suggest we would see in terms of warming when you take into account the two other factors that could influence warming in this time frame, namely solar variations and volcanic forcings. And as you can see, there's no correlation really between the observations and the model when one just accounts for solar volcanic impacts. However, when you add the greenhouse gas forcing, lo and behold, you get a very good correlation between the actual warming that we've seen and the projected warming that the models suggest. So there's a pretty clear indication that we're the problem, humanity. And you'll see a graphic that I've generated that would reinforce this conclusion. As mentioned in the previous graphic, this is another strong signal that humanity is the problem. What I've done here is to basically compare actual warming all the way up through 2017 per NOAA, alongside a projection with the model that I played with, this Magic Live model, assuming middle-of-the-road model assumptions and an emission scenario that assumes quite a bit of fossil fuels. It's called a fossil fuel intensive emission scenario. And as you can see, there's a very good correlation between the actual warming and the projected warming. Also noteworthy is that if you look out several years, we will be coming up with 1.5 degrees Celsius warming as soon as 2030. And we could achieve 2 degrees Celsius warming somewhere in the order of 2045. So as you might judge from these numbers, we need to get our act together as soon as possible. We need to lower those emissions dramatically as soon as possible if we're to avoid going well above the 2 degrees Celsius mark. And if we don't get our act together, by the end of this century, we could be at the 4 degrees Celsius plus warming and going up fast. The first insert documents that the equivalent of 2.6 billion Hiroshima atomic bombs worth of energy has been introduced in the atmosphere since 1998 because of the enhanced concentration of greenhouse gases in the atmosphere. At the rate of 4 bombs per second, later this century it's projected that if we don't get our act together, that number will be like 12 bombs per second worth of energy. As a result, we've seen impacts even now, much more to come. Changing rain and snow patterns as this heat evaporates water at a greater rate than historical levels. We see changing rain and snow patterns yielding stronger storms. Changes in animal migration and life cycles as they try to adjust to the changing climate. Also changes in plant life cycles as well. Less snow and ice as the snow and ice melts from both mountains as well as ice formations. And this in turn yields rising sea levels. Higher temperatures, more heat waves, as a result, more droughts and wildfires. Warmer oceans, much of the heat ends up in the oceans. The carbon dioxide ends up dissolving, about a quarter of all the CO2 ends up dissolving in the oceans, generating carbonic acid. And the warmer oceans and acidified oceans damage the health of the oceans and specifically damage corals. And then finally, we're seeing evidence of thawing permafrost in Russia, Alaska, and Canada. And this could be very dangerous since this could yield additional emissions of greenhouse gases, namely methane and carbon dioxide. In fact, the Royal Society has basically did a pretty intense study on the implications of a 4 degrees Celsius warming planet and what the implications might be. And as the previous graphics suggested, if we don't get our act together, we could be approaching 4 degrees Celsius later this century. They concluded there would be enormous adaptation challenges in the agricultural sector, large areas of cropland unsuitable for cultivation, declining agricultural yields. At the same time, by the way, the population will be closer to 9-10 billion people later this century. The world will be rapidly losing forests, coastal wetlands supported by an acidified and potentially dysfunctional marine system. Up to 1/2 of all the species will be threatened by some studies later this century if we don't get our act together. Drought and desertification would be widespread, with large numbers of people experiencing increased water stress. Much of the western United States, much of Europe, a large swath of Africa and southern Asia and Australia will be subject to very serious drought conditions over extended periods of time. And then human and natural systems will be subject to increasing levels of agricultural pests and diseases and increases in frequency and intensity of extreme weather events. This does not present a pretty picture, but this is where we're heading, and we've seen the beginning of some of these impacts already. More to come. When we take a look at country emissions historically, who are the bad actors? Who are the countries that have contributed most in terms of, in this case, carbon dioxide emissions are plotted here? And this graphic goes all the way back to basically 1760, the beginning of the Industrial Revolution. And you can see that the European Union, mostly England, started this process way back when. And that's the yellow part of the graphic. Starting in 1800, there was just a very modest amount of emissions back then. And then you can see as we increase, as time moves on, the emissions grow at a very rapid rate. And you can see the key players are European Union, then the United States becomes the big emitter, and in recent years it's been China with their huge population of 1.3 billion people, and India with a similar population is starting to show signs of growth. And you can see other countries are substantial emitters as well. And I note these particular countries and parts of the world, these are basically countries with a lot of people. If you add up their populations, it's in the order of 3 billion people. And they have very relatively low emissions, but very low standards of living. And they want to have a standard of living like we do. And if we're not careful, their per capita emissions will look a lot like those in the Western, more industrialized world, and that would be clearly a step in the wrong direction. Let us now examine this issue from a carbon dioxide per capita perspective. In other words, looking at it from tons per person in a given year. When one takes a look at 2012, and looks at the largest emitters of carbon dioxide, the United States leads the pack at 17 tons per person. Europe, 8.8. China, 8.1. India, 2.4. Other developing nations, apart from India, 3.4 tons per person. And then the world taken together averages out at 4.7 tons per person. When one takes a look at the United States per capita situation, these are the components of the 17.1 tons per person. Shelter, goods and services, car travel are the big ones, other travel, and then food. And this is for CO2 only. When you account for the other greenhouse gases, that number would go up. And as far as global targets are concerned, basically, when you make these calculations, you conclude that the per capita emissions in 2050 would have to be somewhere in the order of 0.6 to 1.6 ton per person if we have a shot at limiting warming to 2 degrees Celsius. So you can see that the world average of 4.7 would have to get down to let's call it 1.6 and be generous. It's a tremendous challenge. And when one takes a look at the Paris Agreement, where promises were made to reduce some emissions or slow down emission growth at least, at the very best, that would reduce per capita emissions to 3.5 tons per person, still well above the required 0.6 to 1.6 per person. Well, let's talk about the subject of tipping points. What are they, and should we be worried? The shorter answer is yes, we probably should be worried, but let's tell you why. This is a concept where global climate can change from one stable state to another, similar to a wine glass tipping over, a threshold which reaches a point of no return, possibly, that can change the planet irreversibly. And let's talk about the points that could cascade yielding such a hothouse Earth, and that's the terminology they use. That if things get out of control, we could actually get moved toward a hothouse Earth with warming moving uncontrollably higher. And this, the phenomena that can catalyze such a reaction include the following. And the models attempt to take into account some of the Arctic sea ice melting, but if this melting would accelerate, and there's some evidence that it is accelerating beyond model inputs, we would then see less reflectivity from the ice, and more warming would be available to heat up the planet and warm the atmosphere. Melting of tundra, Arctic ground in the northern part of that northern hemisphere. This permafrost is a large source of carbon dioxide and methane, and if this starts releasing substantial quantities, it can accelerate this movement toward a hothouse Earth. And if the sinks of carbon dioxide emissions, and about a quarter of the carbon dioxide ends up in the ocean, about a quarter ends up in the forest, the balance into the atmosphere. And if it turns out that as we acidify and heat up the ocean, that it can take less carbon dioxide, and we burn down or cut down more forests that would accept less CO2, more will end up in the atmosphere, potentially accelerating the warming process. And a recent study back in August of last year called The Trajectories of the Earth System in the Anthropocene studied this issue in some detail. And they concluded that when they looked at possibilities of this occurring, that these kind of events could cascade and yield an uncontrollable warming scenario. They felt that there were definitely combinations of events. If the temperature would rise at 2 degrees Celsius or higher, that could make this happen. And they strongly recommended that if we could limit warming to 1.5 degrees Celsius, we would dramatically lower the risk. So should we worry? Yes, we should. This is not by any means a done deal as far as it occurring, but there is really a threat of it occurring. And clearly at 3 degrees Celsius or 4 degrees Celsius warming, the probability of this occurring raises dramatically over just the 2 degrees Celsius, which was evaluated in this particular paper. Well, what is driving this massive and relentless emission of greenhouse gases? And as we say in engineering, you can't solve a problem without defining the problem carefully. And basically, population growth and development pressures spawned by an increasing demand for all kinds of energy and resource-intensive goods, foods, and services are driving growth in greenhouse gas emissions. Population has tripled since 1950, for example. And many countries are urbanizing and demanding additional energy and resource-intensive goods, food, and services. Population has been growing at about 1% a year in recent years. It's projected to be over 9 billion people by 2050. There's been a growing demand for agricultural products, especially meat, which is a large source of greenhouse gases. There's been urbanization, a move toward large, heated, cooled buildings, requiring quite a bit of energy. There's been an increase in personal travel. Everyone around the world would like to have their own car, and much increased mileage from trucks and aircraft as well. And again, the demand for a large array of consumer goods requiring energy during extraction, separation, transportation, and production, and for electronic goods, even during their operation. We have to basically move away from this current approach that humanity seems to have, that if we dig ourselves a deep enough hole, we could have anything we want. I'm afraid that's not the case, given the finite resources of the home planet. Well, what kind of emission reductions are going to be needed to have a chance of meeting those very aggressive targets, the 2 degrees and 1.5 degrees Celsius targets? And note that this graphic by the Climate Interactive Group shows a plot of gigatons of annual CO2 emitted. Note that it's CO2 equivalent, so this now includes emissions of the other greenhouse gases, specifically methane and nitrous oxide. So all three of those gases would have to be controlled. And it shows the emission trajectories all the way to 2050. And let's walk you through these scenarios. The baseline, if no action is taken, we've talked about this one already, we would see about 4.5 degrees Celsius if we continue on our fossil fuel intensive path. If all countries only meet 75% of their Paris targets, the climate accord in Paris, and that seems to be roughly where the world is heading right now, warming would be about 3.7 degrees Celsius. If all the countries met all of their promised goals, that would limit warming to about 3.4 degrees Celsius. But of course, those are very, very far from where we need to be. So what would it take to keep temperature from rising more than 2 degrees Celsius? And this, as you can see, it would be a tremendous amount of reduction would be necessary. You would have to start in no later than 2030 and reduce emissions annually 4.3% per year, all the way to 2050 and beyond. And if you had a shot at 1.5 degrees Celsius, you would have to reduce emissions 7.5% annually and start in 2025. My professional opinion is it is basically impossible to achieve the 1.5 degrees Celsius level under these assumptions, and that the probability is very low that we can achieve those levels of reductions to meet the 2 degrees Celsius target. It should be noted that when modelers take a look at this, they talk, well, maybe what we need to do is remove carbon dioxide from the atmosphere to assist in our emission reduction program. And keep in mind, that's only a technology on paper. There is basically no technology currently available to do that, and the costs would be many trillions of dollars to set up the facilities needed to put a dent in emissions from CO2 emissions worldwide. Now, don't get me wrong, I think this is a good idea that we need to at least look into it and check for feasibility, but it's certainly not on the table as a meaningful mitigation option at this stage of the game. It's important to understand the key sources of greenhouse gases for a given country. This pie chart shows those key sources for the United States. And as you can see, transportation and electricity generation, carbon dioxide, are the most important sources. Together, they contribute almost 2/3 of all the greenhouse gas impacts from the United States. And then there's the industrial sources of carbon dioxide. Cement manufacturing, various chemical operations generate carbon dioxide as well. And then commercially and residentially, the burning of natural gas is a large component of those two categories. And then finally, non-carbon dioxide emissions represent about 17% of the total, predominantly methane and nitrous oxide. Major sources: agriculture, industrial, energy activities, combustion, waste disposal. Many sources, which makes the mitigation challenge quite difficult. Low carbon technologies will play a key role in reducing greenhouse gas emissions globally. And shown in this graphic are the key low carbon electricity technologies. You can see wind energy, solar energy, nuclear energy, all very low carbon emitters, close to zero. And then there's carbon capture and storage, which would be applied to typically a big coal-fired plant or a natural gas power generator. And it's important to note that carbon capture and storage is important on industrial sources as well, like cement plants. And then end-use efficiency, critically important to have energy-efficient buildings with the latest technology, and green vehicles, especially electric and hybrid vehicles, are in that category. And then finally, we have to deal with the other greenhouse gases, and methane is the most important gas outside of carbon dioxide, and mitigating methane from all of its key sources remains a critical challenge and an important array of technologies. So the mitigation challenge is monumental. To meet the 2 degrees Celsius target, steep emission reductions across all sectors need to start no later than about 2030. We've showed you options for 2025 and 2035, yielding zero emissions later this century. And we're going to have to also deal with methane and nitrous oxides as well. And we haven't talked about this much, but it is critically important to move developing countries' growth path away from the rich countries' carbon resource intensive model. You may recall the per capita information I showed, where these countries, like India would be a good example, with 1.3 billion people, they're already at a per capita rate that should not be exceeded if we're going to meet that 2 degrees Celsius goal, and yet they want to have a lifestyle similar to what we have in the Western world, and particularly in the United States. So how do we improve their standard of living dramatically without them moving in the direction that we have in terms of the use of fossil fuels and in terms of our intensive use and requirement for all these foods, goods, and services? And we haven't talked about this, but it's worthy of mentioning. Negative emission technology has been promoted by some as a so-called Hail Mary option. And in fact, you could tell from the analysis I've done that it's going to be almost impossible to get down to 2 degrees Celsius realistically without some other force. And the other force that is being discussed is introduce technology that will directly reduce carbon dioxide from the atmosphere. And this is very similar, actually, to carbon capture and storage technology applied to a coal-fired power plant, except we're now applying it to the atmosphere, which is much more difficult because the concentrations are much lower and the economics are much poorer. These will require trillions of dollars of hardware to both capture the carbon dioxide and ultimately store it probably in underground storage sites. But nevertheless, in my professional opinion, this should be looked at given the hole we've dug. Again, you recall one of the issues that we wanted to deal with in this presentation is, can we achieve the goals that have been set by the international community? And I have concluded professionally that it is extremely unlikely that warming can be limited to 1.5 degrees C. And in fact, the 2 degrees Celsius is questionable as well. So what can be done to move humanity to the necessary low emission path? Well, the countries must set strict emission targets and agree to meet them. The Paris Climate Accord is a small step. First of all, the reductions promised were modest. Second, there were no real forces to make sure that these so-called promises were met. In fact, as you're probably aware, the United States is dropping out of that accord. Other countries such as Russia, Saudi Arabia, it's questionable whether they're going to meet their goals as well. I would argue that probably the most direct and important action that could be taken in the near term is put a serious price on carbon commensurate with its potential impact. And I think we all will admit that the capitalistic model is a powerful model. It can generate a tremendous amount of economic development. If we can utilize and harness that model in a productive direction rather than a destructive direction by putting a price on carbon and having the economies adjust to that price, would clearly move us in the right direction. But the price would have to be high, and it would need to be increased dramatically, progressively. And it has to be international. One country, of course, can't do this on their own. We need to develop and utilize low carbon, low resource intensive technologies. The amount of research, development, demonstration worldwide is much lower than is required. It's not just my opinion. The International Energy Agency has concluded that we're spending about 1/5 what we need to be spending on these technologies to have a shot at meeting these very aggressive targets. And societies need to make fundamental changes. This is not going to be easy, but at least it's got to be on the table, which they are currently not, quite frankly. And then looking at where we stand right now, I mean, this graphic, I think, lays things out fairly clearly. We've overconsumed. We're kind of fat. We got a bib on. We're waiting for more resources. We've already chewed up a good part of the planet, and we're looking for more. Not a pretty picture, but unfortunately a fair one. But I think what we need to remember is that this young lady and her generation, they are the stakeholders. They count on us. They will reap from seeds we sow. Thank you for your attention.